learners, welcome to Education Online program. I'm teacher Willa Lucia. So in our previous lesson, we looked at the thermal expansion in solids, where we said thermal expansion is the increase in the size of an object when it is heated. So today we are going to be looking at the linear expansivity. Has our linear expansivity. Calculating the expansivity of an object will help you know what length did this one increase with, did your object increase with after heating, even what temperature does this object require to increase in that particular length. So when you're talking about linear expansivity, we are talking about a material is the fraction of its original length by which it expands per Kelvin rise in temperature. So we are trying to see how it is going to increase in the length with an increase in temperature. So we can say our linear expansivity of a material is the fraction of its original length by which it expands by a Kelvin can say per Kelvin, it's not by, per Kelvin increase in temperature. So now, like, if you get your object, you heat it up, at what degree have you heated the object? So what is the amount of the heat there? That is the measure of the temperature. So after heating it, what length did it gain after you exposing it to that temperature? So that is what we are going to find. So to find linear expansivity in mathematical form, we shall write it as linear expansivity is equals to the original length you can have it as then expansion over original length times the temperature. So our linear expansivity, we write it as, we give it this symbol. So is equals to, what is the linear expansivity? The linear expansion of the material is the difference between its original length and the length it gained after heating. That increase, so the difference between the two gives you the linear expansion. So how do we get the difference? We can say we need the change in the length. So changing the length will be, we shall have it as dl over our original length. We can make it have L naught. We are multiplying by the temperature. So which temperature are we multiplying it with? So this we need the difference between the temperature that the body originally had, and then the temperature you increase so that it can also increase in length. So we shall have it as a dq. So this means that change in the temperature. So we shall have it now as our expansivity is equals to we shall have our L1 minus L naught over L naught multiplied by the difference in the temperature, which we can have L1 minus the initial temperature. So whereby our dl stands for the change in the length. So we shall have it, we have it as L1 minus L naught. So our L1 stands for the increase in the length. The increased length. Our L1 is equals to the, you can say the increased length, or you can say the final length attained by the object. So our L naught here will be giving us the original length of this material. If it was 100 centimeters before you heating it, that one is our original length. So after heating it, that increase there, for it to be maybe increased by 0.1, so that to 100.1. So the difference there is 0.1. So you will give it L1 will be 100.1, then the original length remains as 100. So we are giving it the L naught. We shall say it is our original length. So down here we have still L naught, which is the original length. We have Q1, and then we have the Q naught. The Q here stands for temperature. So if it stands for temperature, if you have it like dq, that is the change in temperature. So we have our Q naught is the initial temperature the body was having. So like if you're in a room, that room temperature alone, without any air conditioner, or without maybe putting any fire around or cooling the room, that room temperature there is the Q naught. So we say that it is our initial temperature. So now when you change the temperature of the place or the object, that becomes the Q1. So the Q1 becomes our final temperature. We shall have this as our final temperature. So if you now know these ones like that, after them giving us a question, how shall we interpret the question into this? How shall we know that in the question actually we have the initial temperature? How can we know that the figure being given is the original length? So by that, let's look at this the example. But before we go to the example, remember there is always SI unit. So for expansivity, what could be the SI unit? So our SI unit of expansivity can either be per Kelvin can write it as per degree Celsius. So that means that it has 2 units. So we can have it as per Kelvin, which is written as K power -1. That -1 there on top is the per. Or we can have it as per degree Celsius. So we shall have it as our per there, which is the power -1. So let's take a look at this example. Our example says, in an experiment, to measure linear expansivity of a metal rod, the metal rod is 800 millimeters long. Is found to expand by 1.36 millimeters when the temperature there rise from 15 degrees Celsius to 100 degrees Celsius. So here is our question saying that in an experiment to measure linear expansivity of a metal rod, the metal rod is 800 millimeters long, is found to expand by 1.36 millimeters when the temperature rises from 15 degrees to 100 degrees. So in our question, have they given us the linear expansivity? The question does not have the linear expansivity. It actually is demanding, the question is demanding us to find the linear expansivity of this material, which is the metal rod. But how long was the metal rod before heating? So you see that our metal rod was 800 millimeters. So before heating, we shall have our original length of this metal, assuming this is our metal. Let's have a metal here. So the length is from this point here up to there. So this one here has been measured and is found to be 800 millimeters long. So if it is 800 millimeters long, they're saying is found to expand by 1.36 millimeters. So meaning that after heating this metal rod, it did not maintain its length, but then it increased in length, and it increased by that value there. So instead of it remaining to this length, there was an increase here. We're going to use a dotted line to show the increase after hitting this rod. So this increase is what? That is from here. From this point where it had ended, the original length ended up to this point here, is what we have as 1.36 millimeters. What about the temperature? What was the temperature of the rod before hitting it? The rod had a temperature of 15 degrees Celsius. So meaning that our initial temperature, the body temperature of this metal rod was 15 degrees Celsius. So after us heating this, after introducing the heat, that means that introducing the heat increases the temperature of the place of the metal rod. So the temperature that was heating it was now giving us 100. It was increased to 100 degrees Celsius, and it is that increase in the temperature that caused the increase in the length. So now we can see that now from there you will see that our L note has been given. Our L note there is L note will give us, which is the original length, 800 millimeters. So if we had 800 millimeters as the original length of the rod, after heating, what length did it gain? It gained the length from 800 here up to that. So you can get your 800 plus 1.6. So if you have, that will give us L1, which will be 800 plus 1.36 millimeters. So if you have it like that, what would be your? So if you add the two, you'll have 801.36 millimeters as the final length gained by the metal rod. So what was the initial temperature of our metal rod? The initial temperature Q naught was given to us as 15 degrees Celsius. So the metal rod was heated, and the heat was increased to, the temperature was increased to 100 degrees Celsius. So 100 there becomes our final temperature. So if we have like that, our formula is saying that make it a bit straight. So our formula is saying that linear expansivity is given by is equals to, we have the change in the length, which is Q L1 minus L naught, dividing it by the original length, and then we multiply it by the change in the temperature, which is Q1 minus Q naught. So what happens is, do we have L1 minus L naught? We can find that. Our L1 minus L naught was already given to us as 1.6. So meaning that even though you add this, you get your L naught, your L1. Then you get your L1 minus L naught, you're still going to get 1.36. So meaning that our L1 minus L naught will be equaling to, that is 801. 0.36 minus 800. So this will give us what? 1.36 millimeters. So if you had this as your difference in the length, what of the difference in the temperature? When we have our Q1 minus Q naught, what will be, what will it equal to? Our the temperature, the final temperature of the body was raised to 100. So we shall have 100 minus, we have now the initial temperature, which is 15. We are subtracting 15 from it. So this will give us, this will be equaling to, you have your 100. We have 100 and we are subtracting 15. So what do we get? You will cancel, you borrow 1, then you borrow again 1, this one will remain 9, this one remains 0. You borrow 1 here to make this 10. So 10 minus 5 will give you 5. Here we were left with 9. So 9 minus 1 will give us 8. So this is 0 minus 0, which is 0. Meaning that our 100 minus 15 will give us 85. 85 what? It will give us 85 degree Celsius. It is the temperature. So now we now take the figures and we substitute in our formula. So we shall have our expansivity, which will be equaling to our L1 minus L0, which is 1.36, divided by our L0 is given to us as 800. It is the original length. So we shall have here 800. 800 times what? This is 1.36. So we shall have 800 times, this is the difference in the temperature, which is 85. So our linear expansivity, now if you get 800 times 85, what shall we have? We have our 800, we are multiplying it by 85. So we shall have 0 times 5, which will give us 0. 5 times 0, this is 0. And then 5 times 8, what shall we have? 5 times 8 will give us 40. Because if you take 5 times 5, that is 25. Times 6 is 30. Times 7 is 35. Times 8 will give you 40. So now we have 8. 8 times 0 will give us 0. 8 times 0 will give us again 0. 8 times 8 will give us 64. So we are adding the 2. This is 0 plus nothing is 0. 0 plus 0 is 0. Again we have 0. 4 plus 4, which will give us 8. And then we have it plus 6. Meaning that our 800 times 85 will give us 68,000. So we shall have our expansivity here, which will give us 1.36 divided by, this is 68,000. So if we have our expansivity is equals to 1.38, which we are saying is this divided by this, what shall we have? We shall have 0.00, I have 0 again and then 0, 2. This time it is, don't forget the SI unit, which is per Kelvin there. So this is the linear expansivity of our rod. So the main issue here is for us to find the initial temperature of the body. If we know the final temperature, then we get that we know the original length and then the initial length, because it can sometimes be a bit confusing to find the original length. Now, like in this question, they had given you already the 1.36. Someone might think it is actually the original length. This 1.36, it's just that slight increase. So if it is the slight increase, how would you get the final length obtained by the object? You just get the two, you add the original length, and then you add the little increase to find that. If you do not want to do that, then you can just go direct and do it this way. So this is how we deal with linear expansivity in solids. So in our next lesson, we shall be looking at the expansion of liquids. How do liquids actually expand? So with this, we come to the end of our lesson.